The Fuel Cell Seminar and Exposition joined with the U.S. Fuel Cell Council and the Connecticut Hydrogen and Fuel Cell Coalition to put this distinguished panel together for the purpose of exploring the synergies between the fuel cell and natural gas industries. The convergence of fuel cells and natural gas in our migration to a clean energy economy has been driven by a number of factors. Natural gas is the cleanest fossil fuel available in abundant supply from domestic reserves and is experiencing historically low prices. At the same time, tax incentives at both the federal and state levels are fostering the deployment of fuel cells for a broad range of applications, from portable to stationary to mode of transportation and power generation. Natural gas can be reformed internally to power stationary fuel cells or to generate hydrogen, which can then be used to power fuel cells for other applications. But unlike conventional combustion systems, fuel cells increase the efficiency of natural gas by as much as 30%, while virtually eliminating noxious emissions and lowering greenhouse gas emissions by 20% or more. And although both fuel cells and natural gas can be used to generate power in central power stations, their greatest advantage is to distribute power generation closer to the point of consumption, eliminating the losses associated with grid transmission, alleviating grid congestion, and enabling grid-independent power generation at times of national emergency. With demand for clean, efficient, and reliable power increasing, it is natural for these two industries to come together now. Even Energy Secretary Chu has publicly acknowledged that the most efficient and environmentally sound way to take advantage of America's substantial natural gas reserves is to process natural gas with fuel cells. Bless his heart. Today we have representatives from a cross-section of the natural gas and fuel cell industries to discuss the possibilities for collaboration that can bring us closer to our economic, environmental, energy, and national security goals. Ralph Cleveland is the Executive Vice President of Engineering and Operations at AGL Resources. AGL Resources is one of the nation's most efficient operators of natural gas distribution systems, with business segments covering natural gas distribution operations, wholesale services, and energy investments. Richard Hoffman is the Executive Director of the Interstate Natural Gas Association of America Foundation. INGA is a trade organization that advocates regulatory and legislative positions of importance to the natural gas pipeline industry in North America, representing virtually all the interstate natural gas transmission pipeline companies in the US, as well as the comparable companies in Canada and Mexico. James Marion is the Senior Program Manager of the Delivery Sector at the Gas Technology Institute. GTI is a not-for-profit research and development organization and a leader in the development and deployment of technology solutions that contribute to a secure, abundant, and affordable energy future. David Tycrobe is the Business Development Director of the Fuel Cell Markets at Enbridge Incorporated of Toronto, Canada. Enbridge transports energy, operating the world's longest, most sophisticated crude oil and liquids transportation system. They own and operate Canada's largest natural gas distribution company, and they're expanding their interests in renewable and green energy technologies, including wind and solar energy, hybrid fuel cells, and carbon dioxide sequestration. Michael Brown is the Vice President of Government Affairs and the General Counsel of UTC Power. UTC Power is a unit of the United Technologies Corporation and is a world leader in developing and producing fuel cells that generate energy for buildings and for transportation, defense, and space applications, including the support of US manned space flight since the mid-1960s. And Frank Wallach is our moderator for today's panel, and he is the Vice President of Business Development and Government Affairs at Fuel Cell Energy. Fuel Cell Energy is a global leader in the manufacture and commercialization of stationary electric power generation systems. So I'm going to turn the panel over to Frank, and he's going to lead you through a discussion about the natural synergies between natural gas and fuel cells. Thank you.
Thank you, Ruth. The format for this panel is going to be really a Q&A dialogue, almost an interview format among my panelists here. And I'd like to start with two things. One, I'd like to go across to my panel members and have each of them, if they so desire, make some comments about what they might do specifically for their organizations. And then we are going to have David Tycrobe come up and give a very brief overview of some interesting application that Enbridge is doing. This should frame the conversations that we have among the panelists and myself, and really set the tone for this forum here today. So with that, perhaps I can start with Mike. Mike, if you would be willing to say just a few words, either sitting or standing.
I'll stand up, Frank. Good afternoon. As you were told, I'm Mike Brown. I'm with UTC Power. We've been in the fuel cell business now since 1958, and we've done just about everything you can do with fuel cells, using virtually every type of fuel cell that's out there. And I think for purposes of our discussion today, it's important that you understand that we produce a 400 kilowatt phosphoric acid fuel cell that we like to put into commercial application as distributed generation. Some of our biggest current users are supermarkets, and they take advantage of not only the electricity we generate, but also the thermal energy for heating and cooling in grocery stores.
Jim, would you care to tell us about GTI?
Thanks, Frank. My name is Jim Marine. I'm with the Gas Technology Institute. I joined the Gas Technology Institute this past April after spending about 30 years, a little over 30 years, with a local distributing company of New York State Electric and Gas, and then most recently they combined with Rochester Gas and Electric. That would be in upstate New York. I've spent roughly the last 15 years of that particular part of my career doing research and development activities, focused on a variety of things, most recently distributed generation, microgrid type activities, as well as compressed air energy storage. My role at Gas Technology Institute is the area of working toward a vision for the smart energy future for natural gas industry.
Ralph, would you care to talk about AGL?
Good afternoon. Absolutely a pleasure for me to be here with you this afternoon. First, let me give you the AGL Resources commercial. We are the second largest distributor of natural gas, the largest east of Mississippi. We serve, or we own 6 utilities up and down the East Coast, a total of 2.3 million total customers. I have primary responsibility for development of all of the assets that are all the hard assets within the company, as well as all of the technical operations, engineering, all the construction associated with the company, as well as all of the supply chain, including gas supply. So this issue of how do we best utilize that infrastructure that is already existing within the natural gas industry, I think is a critical one. And we look to leverage that infrastructure in as many ways as we can, particularly as we think about a smarter energy future. I would also say I wear a hat as a managing committee member of the North American Energy Standards Board. That's an organization of about 300 industry participants, if you will, that set the standards for commercial operation within the energy sector, both electricity and natural gas, retail and wholesale. One of the things that we've been working very diligently on over the past year and a half has been standards associated with smart grid. And so this issue of how we think about the integration of natural gas and smart grid and the implications upstream is a very important conversation as well. Also, in my background, I spent about a decade working in oil and gas, primarily gas production. And so all of those things bring my level of interest, my own personal level of interest with respect to the use of natural gas and the potential implications and applications associated with fuel cells to a very heightened degree. So again, a pleasure for me to be here with you.
Richard, your turn, a few moments.
Thank you, Frank. Good afternoon, everyone. My name is Richard Hoffman, and I'm with the INGA Foundation. The INGA Foundation is the research arm of the Interstate Natural Gas Association of America, and that's the short for that is INGA. The only pipeline operating companies can be members of INGA. On the other hand, the INGA Foundation represents the entire value chain. So we have equipment manufacturers, steel mills, engineering design companies involved in our foundation, and the primary purpose is to look for ways to improve the efficiency, the safety, the operation of a reliable interstate natural gas pipeline system. The foundation is one of the sponsors of the GTI study on the vision for natural gas in a smart energy future, and we'll talk about that today. We're also working on a study right now on the impact of increased electric renewable generation on natural gas infrastructure, which will be coming out in another month or so. Prior to the Inga Foundation, I worked for FERC for 34 years, and my group was responsible for the pipeline projects and liquefied natural gas projects, environmental and safety reviews all over the U.S., Alaska, and other places. Thank you.
Thank you, Frank. Good afternoon, everyone. I'm with Enbridge, Inc., and we're an energy transportation company. And I guess maybe I'll take things to another direction just to frame what we're going to do. I'll take responsibility if this panel doesn't do well in your opinion at the end, because I didn't frame it right. But if they could cue up the presentation.
Good.
So just a little bit about Enbridge and why we are here speaking about fuel cells. We're an energy transportation company, be it liquid hydrocarbons, natural gas transmission, natural gas distribution, and increasingly alternative or green energy. And when you look at that footprint for the company today, this is important, I think, for fuel cells, because we started as an organization investing in fuel cells back around 2000. We thought the technology was approaching the point where it was ready for some mainstream applications. The vision at the time was it would be in every one of our customers' basements, but nonetheless, we thought that this was a green or alternative technology that was about to be mainstream. Since 2000, when we didn't have much in the way of a green energy footprint, we now have 850 megawatts. 2.2 megawatts is in the fuel cell space, and to a large degree, we see a lot of barriers in the regulatory and the policy side stopping us from pursuing what we think is a technology we can invest in that offers society and the energy industry a great deal of benefits. So just when you look at the application that we have invested in, this is a pairing of two low-carbon technologies. We call it a hybrid fuel cell application. In essence, it allows natural gas utilities to control the pressure on their pipeline in a more efficient and lower polluting way. This plant is in an urban center, about 30 feet or less off an urban sidewalk, and produces enough power for about 1,700 homes without any smog or air pollutants. When you look at its visual footprint, we say it's about 2 tennis courts. And if you were to be looking just to the right of this picture, our nearest residential neighborhood is within a couple hundred yards, maybe 300 yards. Clearly, the fuel cells, for their low noise electrochemical application, they are a very good fit for predictable energy deliveries in urban centers that are increasingly difficult to put any other kind of infrastructure, be it electric transmission, other green technologies, or new power plants.